Hi guys and welcome back. In this video we're going to talk about equivalent fractions. So what are equivalent fractions? What does that word equivalent even mean? Well, you might think that it sounds like the word equal, and I guess in a way that's what it relates to. So what are equivalent fractions? Well, these are two or more fractions that have different numerator and denominators, but they represent the same numerical value. So they look different, but if we were to color in or shade that much of a certain shape, it would still represent the same amount. So we're going to do some examples to make this a bit easier, but we'll look at this one first, okay? We've got this little table over here, and you've got this in your sheet. You do have an extra column for diagram, and that's where you can draw these little shaded diagrams there. So, firstly, we're going to look at shape A, and we're going to call this one shape A. So shape A, how many parts are there? There are 5 parts in total. So 1, 2, 3, 4, 5. And how many parts are shaded in? Well, that's 2. And so if we put this as a fraction, we've got 2 parts shaded out of 5. So if we now do another one where we're going to look at this shape, we haven't changed the shape at all. We've simply split the shape in half again. So how many bits or parts do we now have in total? So we have 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So essentially, we have doubled this. There's 2 lots of this now. And so now how many parts do we have shaded in? Well, there's 4 there, which means that this is twice as many as the previous one. So we have 4, and we say that we have 4 out of 10 parts shaded. Now, these are what we call equivalent fractions. We didn't change this shape or the amount of this shape shaded. We simply cut it into smaller sections. It still represents 2/5 of a whole, okay, even though there's 10 bits, because it's equivalent to 2/5. Let's do another one. Let's look at C. So this is shape number C. How many parts do we now have in total? We have 15. And that means that the number of parts shaded, well, we had to multiply 5 by 3 to give us 15. So we're going to multiply 2 by 3 to give us 6. So in total, we have 6 out of 15 parts shaded. And the last one, we're going to cut it again. And this time we have 20 parts shaded in total. And so we multiplied 5 by 4 to equal 20. And then we multiply 2 by 4 and we get 8. So in total, we have 8 out of 20 parts shaded. And these are all equivalent. They all represent the same amount of a whole, the same percentage of our shape. Now, let's look at another way of doing it where we don't have to draw a shape every time. Okay, so first thing we're going to do is we're going to find an equivalent to 2/5. Now, this is what we did before, but I'm going to show you a different step. So 2/5 equals, and we're trying to find an equivalent fraction. So if we were to multiply 2 by 2, what do we get? We get 4. And if we multiply 5 by 2, we get 10. So an equivalent fraction here is 4/10. The important thing to remember is you need to do, whatever you do to the numerator, you need to do to the denominator, so that they're both being multiplied or divided by the same amount. So let's do another one. So we have 6/11 equals, and we've been given the number 24, but we're trying to find out what the denominator is. So what we're going to do is we're saying, well, what has 6 been multiplied by to make it equal 24? And so if you count your times tables, 6, 12, 18, 24, we've multiplied it by 4. Okay, and so remember, whatever we do to the top or the numerator, we need to do to the denominator, which we then multiply it by 4, and we get the number 44. So 6/11 is equivalent to 24 44ths. So 24 out of 44 parts. Now we can do the opposite, where we're going to find some smaller fractions, okay? So in these previous ones, we went from a small fraction up to a large fraction by multiplying them. Now we're going to go the opposite direction when we're going from a large fraction to a smaller fraction, and we call that simplifying fractions. Now, whenever you solve a problem, you always leave a fraction in its simplest form. Now, we talked about this a little bit when we looked at mixed numbers and improper fractions and converting between the two. Well, now, no matter what, we leave them in simplest form, whether that means we're simplifying a fraction down by finding common factors, or whether we are converting it to a mixed number. That is all called simplifying fractions. So to simplify fractions, the first thing we need to do is find the factors of the numerator and denominator. So let's list the factors of 24. We get 1, 2, 3, 4, 6, 8, 12, and 24. And the factors of 54 are 1, 2, 3, 6, 9, 18, 27, and 54. Now you're going to circle the highest common factor. So in this case, the highest common factor, if we start from this end, we have 24, and there's no 24, so it's not that. We might get a pen, so it's not 24. We don't have a 54, we don't have a 27. There's no 12 in both of them, and there's no 18 in both of them. There's no 9 in both of them, and there's no 8 in both of them. There's a 6 in both of them. So we circle our 6, and that's our highest common factor. Now we're going to divide the numerator and denominator by the highest common factor. So 24 54ths, we divide the numerator by 6, and we divide the denominator by 6 as well. And so what we end up with is 24 divided by 6 gives us 4, and 54 divided by 6 gives us 9. Now, we're going to simplify the following again. We'll do the first one together, and then you can do the rest, or the last two on your own. So, simplifying the following. So what we're doing is we're finding the highest common factor. Now, I'm not going to list them out this time. I'm just going to know that the highest common factor in this case is 7. Okay, so sometimes you don't need to list them. You know you can work out the highest common factor or a factor that goes into both. So 7 goes into 21. Oh, I did write them out. 7 goes into 21 3 times. And it goes into 49 7 times. So then what we say now is that 21 49ths can be simplified down to 3 7ths. Now, the next one I didn't write out the factors for, but we're going to look for the highest common factor of 45 and 65. Now, 2, we don't need to simplify that down any further. It is in its simplest form, so we're going to leave that one alone. Now, 45 and 65 have the highest common factor of 5. And 5 goes into 45 9 times, and it goes into 65 13 times. So our final answer here is 2 and 9/13. Now don't forget to keep that 2 there. Okay? Pause it now, come back, and we'll do the last one together. So with this last one, I'm going to show you what happens if perhaps you don't get the highest common number, but the highest common factor, but you still get a factor. Okay, so in this case, I'm going to go, well, maybe a factor, the highest common factor is 2. So I'm going to do divide both by 2. So 2 goes into 18 9 times, and 24 divided by 2 gives us 12. Okay, so we go down and we've got 9/12. Now, every time you get to a new fraction, you're going to say, well, is this in its simplest form? Are there any other common factors? And I can see here that a common factor of 9 and 12 is 3. So 3 goes into 9 3 times, and it goes into 12 4 times. So our final simplified answer here is 3/4. Now, we're going to go on to comparing fractions. So when comparing fractions, we use 3 symbols, and you probably have seen these symbols before. We use the greater than symbol, and I use a crocodile because I think, the crocodile's always going to eat the biggest. And I always use the example that if, you guys who are nice, small and skinny and not very meaty are out in a river, well, a crocodile's going to enjoy eating me more than they're going to enjoy eating you because I've got a bit more meat and fat on me than you guys do. So I always think, well, they always eat the bigger thing. And in this case, the crocodile always eats the bigger number. So we have this, in this case, we're saying 2 is greater than 1. And this one here, because we're showing it in terms of these two in relation to each other, we're going to say 1 is less than 2. So the crocodile's eating the biggest number. And then the final one, which is 1 and 1, so is equal. Crocodile can't eat anything, or it eats both. So these are the way that I remember it, and it's nice and easy that way. So let's talk about which fraction is larger. So let's compare these two. Now, when comparing fractions, they must have the same denominator, so the same bottom number. So what we do is we list the multiples of both the denominators. So we're going to list the multiples of a heap of multiples of 5, which is 5, 10, 15, 20, 25, 30, 35, 40. And then we're going to list some of the multiples of 7, which is 7, 14, 21, 28, 35, 42, and so on. And then you're going to find this, circle the lowest common multiple. And the lowest common multiple in this case is 35. There are no numbers below it that are common in both. So now what we do is we multiply the fractions, so both the fractions, so that the denominators are equal to each other, equal to the lowest common multiple. So 3/5 equals something over 35. So what did we have to multiply 5 by to make it equal 35? Well, 1, 2, 3, 4, 5, 6, 7. So we went 5 times 7 gives us 35. And if we remember back to before, I said anytime you multiply or divide a denominator or numerator, you must do it to the other part of the fraction. So in that case, we're doing 3 times 7, which gives us 21. Okay, so now what we're going to do is look at 4/7. So 4/7 is equal to something out of 35. So we're going to multiply 7 by 5 to give us 35. And then we do 4 times 5 to give us 20. So now to find out which is larger, we compare the numerators or the top number to see which is larger. So here, where's my arrow? Here we have 21/35 and here we have 20/35. So if we look at these two, this number here is actually bigger than this number. And so what we say, and we always compare the original fractions, we say that 3/5 is greater than 4/7. Okay guys, that's it. If you have any questions, make sure you ask. Otherwise, I will talk to you in the next video. Thanks guys.